Okay, so today we're looking at how to solve trigonometric equations. This is a very important skill. You will definitely need to be able to do this in the exams. Sometimes it's in the tech-free exam as well, relatively often in fact. So it is something that you really should work on learning how to do. So we're going to go through that process today. Alright, so let's think about what this means to start with. If we're solving an equation of cos theta equals half, the way we would normally solve an equation is we're trying to get theta on its own. We would take inverse cos of both sides of the equation, giving us inverse cos of 1 over 2. If you were to put this into your calculator though, you're only going to get one solution. But when we think about what this actually means, in terms of our cos graph here, this is our cos graph, our graph of y equals cos of theta. And we're wanting to find where this is equal to half. That means we're wanting to find where y is equal to half. If I was to draw a line along here, we're getting our values where cos theta is equal to a half. As you can see, we're actually getting a number of solutions. We've got, in this graph shown, we can see we've got 4 different values, but if I was to just type inverse cos of half into my calculator, I would only get one solution. I would only get this solution right here. So we need to think about how we can get these other solutions, and we do that by using the symmetric properties that we talked about earlier. At the moment, as this is written, cos theta equals half, we would have infinitely many solutions because the graph is going to continue to infinity and to negative infinity. So we're going to get infinitely many solutions. Now that's not feasible to list infinitely many solutions. So what we do instead is that we need to be given a given domain. And once we have a specific domain, for example, if we knew we were just interested in values between 0 and 2 pi, then we would just be looking at these two values here and here. So when we're solving equations, the first thing we need to do is to check the domain. So what I mean by that is that we've got to think about if the domain matches the argument. If I had the equation cos of 2x, that means I would need to be making sure that the domain also had 2x written there, so it matches the argument. The second step we do is we consider which quadrants are required. So if I was solving the equation cos of 2x equals negative half, I would need to think which of the quadrants, if we've got a little unit circle drawn here, doesn't matter that it's not overly accurate, but here's our unit circle. Where is cos negative? Because we had a negative value here. We know we'd be looking at the second and third quadrants. Then we find the solution in the first quadrant. So we think, okay, we would think cos of what equals half, and we'd be finding the first quadrant solution. We extend this to look at all solutions in the given domain, and then finally we solve for x. If I was using this example done here, I would have got 2x equals a whole range of solutions. To solve for x, I would then need to be dividing by 2. Alright, so we're wanting to solve where cos of theta is equal to a half. If we consider the domain to start with, the argument theta here matches with theta here. So we don't need to alter the domain in any way. Step 2 was to consider which quadrants are relevant. So we need to look at the unit circle. I recommend that you draw a rough, quick unit circle so that you know exactly what you're thinking about. We want cos theta equals half, so we want to know where cos is positive, which is in the first and the fourth quadrants. Our next step, we need to think about what our base angle is, and our base angle is another name for the angle we're finding in the first quadrant. So we're thinking cos of what is equal to half. This is where it's really important, and I've said it a few times, this is where it's important that you need to know your exact angle values. And hopefully you're remembering that cos of pi on 3 will give us an answer of a half. We're almost there. We're up to the fourth step where we now work out our values for the different quadrants. So we would get theta that we're looking for here is equal to, our first solution is in the first quadrant, so it's just pi over 3. Our next solution that we're looking at is in the fourth quadrant. So when we're thinking about this, we need to consider how we would get to the fourth quadrant. So remember, we have to measure all the way around. We're going in an anti-clockwise direction to 2 pi, and then we're going to have to subtract back here our value of pi on 3. Okay, so the value that we're looking there, we need to be using those symmetric properties that we've used before. Sorry, just give me a minute while I get my pen working again. So what we're doing is we're taking 2 pi, because we go all the way around to 2 pi, and we're subtracting pi over 3. Okay, so if we work this out, our first value is just pi on 3. When we're working out the value of 2 pi minus pi on 3, we need a common denominator. The common denominator in this case would be 3. So I need to multiply 2. To get a denominator of 3, I need to multiply numerator and denominator by 3, so I'll get 6 pi minus pi. And when we work, our first value is still the same, and the final one, 6 pi minus pi, gives us a value of 5 pi over 3. Final thing that we do need to consider, we do need to think about, so this time we're looking the same thing. Again, we consider, does the argument match the domain? And this time it does not. So that means that this time we need to alter our domain so that it's in terms of 2x. This means we've multiplied x by 2 to get that value. 0 times 2 gives me 0, and 2 pi times 2 gives me 4 pi. So that's our first step taken care of. So now we've got a new implied domain of 0 to 4 pi. Next step, we consider our unit circle. So we've got our unit circle here, and we're thinking about what's happening at each stage. We want to know where sine is negative. Sine is negative in the third and the fourth quadrants. Step 3, we consider what is our base angle. So we're thinking sine of what equals a half. Sine of what equals a half, and again this is something that you do need to know. So we would get pi over 6. Now we're ready to go with our step 4. We're taking inverse sine, essentially we're taking inverse sine of both sides to find multiple solutions. So let's think about how we can reach these solutions. Our first solution, we'll need to go to pi and then add pi on 6. Then to get to our next solution, we would have to go around to 2 pi and subtract pi on 6. Remember, that's not where we stop because our new implied domain goes to 4 pi. So we would have to go around to 2 pi, then we continue around the unit circle to 3 pi plus pi on 6, and then finally to 4 pi minus pi on 6. So do keep in mind what we're looking at now, so that is what we have to be aware of. So our solutions then, like we mentioned before, we would get pi plus pi on 6, 2 pi minus pi over 6, 3 pi plus pi over 6, and 4 pi minus pi over 6. We work out these values, and if it's useful, then definitely write them all with a common denominator. Pi is the same as 6 pi on 6, so 6 pi on 6 plus pi on 6 gives me 7 pi on 6. 2 pi is the same as 12 pi on 6. 12 pi minus pi gives me 11 pi over 6. 3 pi is the same as 18 pi over 6, so 18 pi plus pi gives me 19 pi over 6. And finally, 4 times 6 gives me 24 pi. 24 pi minus pi gives me 23 pi over 6. This is not the final answer because we had a 2 here. So we then need to solve for x, which means we need to divide every term, every solution by 2. When I divide by 2, so if we just consider for a minute, what I'm doing is I'm saying 7 pi over 6 divided by 2. That's the same as saying 7 pi over 6 times. We can change the divide to a times and flip our fraction over, times a half. Multiplying numerators and denominators would give me 7 pi over 12. So when I divide by 2, I'm essentially just changing the denominator of all of my fractions here to a 12. Remember that before we consider this question completed, we do need to think about what the original domain was and check that our final solutions fit within our original domain. The original domain was from 0 to 2 pi. 7 over 12, that's less than 1, so that fits. 11 over 12, that's less than 1, so that's between 0 and 2. So in this one that we're looking at here, the main difference this time is that the domain is given in terms of degrees. Okay, so it's a little bit different when we're looking for answers in terms of degrees. So when we're solving this, we're going to take the same process again that we have done every other time. So we will need to start by comparing the domain. We have x and we have x, so we don't need to change anything there. Second step, like always, is to look at the unit circle. So we're looking at our unit circle, and this time we're asking ourselves, for what values is cos a negative value? Okay, so where is cos going to be a negative value? And we should know that cos is negative in the second and third quadrants. Okay? Then we're doing our base angle. We're asking ourselves cos of what equals 0.7, or inverse cos of 0.7. Now this is something that is not one of the special angles. So how would we figure this out? To figure this out, you're going to have to just actually put it into your calculator and figure out what is inverse cos of 0.7. Now the funny thing about this is that if we were doing this in a tech active situation, we probably wouldn't even need to go this far, because if we were doing this in a tech active situation, we would have just typed the whole equation right from the start into our ClassPad Casio calculator, and it would have allowed us to solve it just like that. But just for the sake of, for interest's sake, we will actually do it. If you've got your calculator, please do it yourself to check as well. But inverse cos, make sure your calculator is in degrees mode, not radians. We need it in degrees because our domain was in degrees, and it will give you the value of 45.57. So then if I'm trying to find my values of x, well, my solutions, the solution in the second quadrant, normally we would say pi minus the value, but it's in terms of degrees. So this time I have to do 180 minus my value here, 45.57. And to get my next value, 180 plus 45.57. Oh, sorry. Use your calculator to work out what these values are. That would be the easiest way to do it. So if you're using your calculator to do this, we would get the first value, 180 minus 45.57 134.57 is going to give us 134.43, and our second value would give us 225.43. Now, that's not right, is it? Sorry, that doesn't make much sense. Let me just check that again. Sorry, bear with me a second here. So let's just get rid of that bit there. Get my pen back again. When we're adding it, sorry, it would be 225.57. Because this was a degrees question, we do need to put the degrees symbols there, okay? Just on another note, when we were getting our answers before, the radian symbol that we can use is a little c. It's not necessary when things are given as pi, but if I was giving an answer in radians like 0.52, I would need to put the c there to be clear that I'm talking about radians and not degrees. So that's just a little side note that our radian symbol is a little c as a... Okay, so our last example for today. Notice that this time we've got quite an interesting domain here. From negative pi on 4 to pi on 4, in union with from pi on 4 to 3 pi on 4. So notice the pi on 4 value is not included because we have round brackets, but we follow the same steps. We look at our argument, 2x, but this is an x. So I need to change it. I need to multiply by 2. If I'm multiplying by 2, I'm multiplying everything else by 2. Pi on 4 times 2 would give me negative pi on 2. Multiply by 2, it's going to 2 pi. In union with from pi on 2. 2 multiplied by 2, it goes to 3 pi over 2. So let's think about what that actually looks like if we've got our unit circle. Okay, here's our basic little unit circle that we've used many times before. And if we are actually considering what this means, well, we've gone from negative pi on 2 to pi on 2. This is negative pi on 2. So we're going from this point here, negative pi on 2 here, around to pi on 2, round up here to pi on 2. Then we're going from pi on 2 around here to 3 pi on 2 because it has the same value there. Okay, so we need to think about which way we're going. We're measuring, so to get to negative pi on 2, we're essentially measuring backwards to get to negative pi on 2 and forwards the other way. Alright, the next step is to consider which quadrants we're looking in. Our square root of 3, that's a positive value. Tan is positive in the first and the third quadrants. Next step, we think about what our base angle is equal to. So our base angle, tan of what is equal to root 3. What we're essentially saying is inverse tan of root 3. What would be our angle in our first quadrant? Once again, you do need to know these, and we would get an answer of pi over 3. Then we're ready to find our solutions. So therefore, we get that 2x is equal to. So to find our solutions, we're starting at negative pi on 2. So let's think again about our domain that was given. So we've gone from negative pi on 2, which is here, from negative pi on 2 to 0. There are no solutions in that quadrant. From 0 to pi on 2, there is a solution here. Our solution in the third quadrant, we'll get there by going from pi plus our value, because we haven't yet got to our 3 pi on 2 around there. So with this domain, you just have to be very careful about how you will obtain the different solutions. So our first solution is just going to be pi over 3, and our next solution will be found by going to pi and adding on pi over 3. We can simplify these values, so we'll get pi over 3. Pi is the same as 3 pi over 3. Add it together, it gives me 4 pi over 3. Finally, we need to divide everything by 2, which will give me pi over 6 and 4 pi over 6. Now this is something important to remember. In exam 1, you must always give your answers in the simplest form. It's not okay to leave it here with a 4 pi over 6. you should be able to recognise that 4 pi over 6 is the same as 2 pi over 3, because we can divide numerator and denominator by 2. Final step, we think about, we consider, we check, do these solutions fit within our original domain? Pi on 6 is between negative pi on 4 and pi on 4, so that fits.